Recording has started. Great. So welcome everyone to this webinar on modular product design. My name is Wilfred Knol. I am here today with András, my colleague. Jannes is also in the audience, and I saw Mike as well. So welcome to this webinar of the University of Applied Science and the Lectorate Lean Research Group in specific. Today, András will talk a little bit about some different tools and techniques on modular product design, product architecture, modularization. It's sort of a general overview, so it's very good if you have little understanding or are orientating or just curious to learn more. It gives you a nice overview of a couple of tools and techniques, methodologies out there that you can use in your approach to modularization. There's other masterclasses and webinars and workshops that really dive into different tools, but that's not what we're going to do today. This is very more in a generic sense. So it's good that you're here. András is my colleague. He studied automotive engineering in Hungary. He's from Hungary actually, and he studied systems engineering here at Han University of Applied Science, his master's degree, and he's currently working here for I think over a year already. Time flies. So he's working on a couple of projects on product design and product architecture, and he's happy to share some of his findings and the content he learned. So András, if I can give the floor to you.
Thank you, Wilfred, for the short introduction. First, I would like to give you an overview on the content that we'll go through today. So first, I would like to give you some insights on generally modular product architectures. What is it actually? And what are the steps that you need to take in order to modularize your product? And what we'll discuss in details today is the tools and methods that you can use for product modularization. And for a short time, I was working for Factory Zero. This is a company in the Netherlands, and I've applied these tools during their design process. And I would like to share you my experience and my overall feeling and the result that we got after the application of these tools. And at the end of the session, I'll just present you a short summary about the learnings that I've experienced based on using these tools at the company. So the first question, what is a modular product architecture? Here in this picture, you see two products. One is an integral product, and the second one is a modular product. They actually both have the same functions, but the architecture, the product architecture, is different. If you have an integral product, then basically the functions and the components have a one-to-one mapping. And if you have a modular product, then one component can have multiple functions. In this case, for example, the handle can have multiple functions because it can drive different kind of screws. So basically both have the same purpose, but their design methodology is completely different. And that's the big difference if you're designing integral or modular. And in the next steps, I'll show you what are the steps that you have to take to design a modular product. And these are the followings. So first, before you start to design your product, you have to get to know the customer needs. So you have to ask questions to your customers, what do you want? And based on those requirements from the customer, you can decide whether it's good to design an integrated product or a modular product. It can be the case that in some cases, it's still better to design an integrated product over a modular product because modular product architecture is not always the best solution. But in some cases, I will show you some examples. It is a very good solution to choose. So after asking your customer, what do you want? You can identify some functions and solutions based on your customer needs. So the customer has a request to you. And then for that, you have to figure out a certain solution. So you have to list some engineering techniques. You have to list some components that you would like to use. And based on that, you can build up the product that you want. And the focus of this masterclass is going to be how to cluster those components that you have identified in the previous steps. So how to create modules. And later during this masterclass, I'll share you some tools and methods that you can use for that. But the question is that how can you separate those components in the product, and how can you separate them in a way that they are forming modules in the product architecture. And as soon as that's done, then you can design the interfaces between those modules. That's a very important step. And the last step is to define what are the configurations and variants that you would like to apply in your product. If you have a product portfolio, then you can have similar components in different products. You can have variants between those product variants. That's the question. What should you choose, basically? But the focus of this presentation is going to be how you identify those modules in the product architecture. I also have a question to you. I'm curious, you see all the steps that you need to take for product modularization. Which one do you know the most about? I'm curious about that. So I quickly launch a poll, and please select the one that you know the most about, or if you don't know about any of these steps that you need to take in product modularization, that's also fine. So I give you a little bit of time. Okay. I see that most of you know most about how to identify functions and solutions. Okay. And identifying modules together with designing interfaces and defining variants and configurations are not as familiar to you as I see. Okay. Thank you for all the responses. And yeah, you can really see that identifying modules is an important step of product modularization. And this is, I believe, this is the core or the most important step that you have to take if you want to design your product in a modular way. So I'm very excited to share you these different tools and methods that you can use for this. Okay, so let me go to the next slide. In the next slide, you will see a video, and this video is about certain advantages and opportunities that you can take if you have a modular product architecture. Okay, so In the video, you have heard some cases in which it is very beneficial to use a modular product architecture. So for example, if you want to release your product quickly, because for example, due to technological changes, or if you want to create a large variety of a product portfolio, then it is definitely beneficial to implement a modular product architecture. But there are some other cases in which you need to consider modularization. And I would like to give you some examples for that in this slide. The first one is product changes. If you want to release your product, for example, yearly, what, for example, Apple does, they have the iPhone and they are releasing a new iPhone every year. And for this reason, they have designed the iPhone in a modular way. So in the iPhone, there are, for example, camera module, there is a screen module, there is a speaker module. And this can speed up their development process, and they can also develop certain modules independently. And this can help them to release the products or release a new product yearly. So that's why they have decided to go for a modular product architecture. But this is not the only one. If you also have high product variety, so you have a large product portfolio, for example, what Volkswagen has, they have the so-called MQB platform. And they can build different kind of cars on this platform. So they have only one platform, and they can build a Skoda, an Audi, a Seat, and a Volkswagen on just one platform. So the variety for the customer, the external variety is quite big because the customer can see different kind of cars. But the internal variety, they try to reduce it. So they try to use components in different kind of cars. And that's how they can basically speed up their development process. The third example is component standardization. So if there are certain standards out there in the industry, this is again the screwdriver example. So if you have a standard, which is, for example, the interface of the bits which are available for the screwdriver, then it's probably worth to implement it in your product, because then you don't need to design the bits, you don't need to manufacture the bits yourself, but basically you can just design a standardized interface in your product, and then you can adapt those standard components which are out there in the industry in your own product. The same one is for manufacturing. So if you don't want to manufacture certain components, but you just want to purchase it from the market, then it's worth to use a modular product architecture, because then you can save some time, development cost, manufacturing cost for yourself. It is important to mention that modularity can either decrease or increase the performance of the product. Here is an example. This is a PC. On the right side, you see a modular setup. This is a desktop PC. And on the left side, you see an integrated setup. This is a laptop. The laptop is basically an integrated solution. If you want to choose the modular way, so to purchase a desktop PC, the performance is going to be degraded, for example, from size perspective, because then you have a bigger product. But for example, you can increase the speed. Usually, desktop PCs have larger speed. So these are the pros and cons that you have to consider if you want to implement a modular product architecture in your product. And the last one is product development management. It is important to consider that if you want to implement a modular product portfolio, then at the beginning you have to spend much more time on the development to prepare the platform for the product. But eventually you can save some development costs later on, because development is easier if you have a modular product architecture. So this is also something that you can consider before you make your decision on going modular product design. I also have a poll again to you. I'm curious which one of these are relevant for your company. So I quickly launch a new poll, and please select the ones. You can select actually multiple ones. Select the ones which are relevant for you. Okay, thank you for all the responses. I see that product variety is the most relevant to all of you. And this is also what I've seen out there in the industry. Companies want to have more and more different kind of product variants because this is what the market demands from them. And this is also the reason why more and more companies are deciding to implement modular product design in their product portfolio, basically. So thank you for all the responses. And finally, in the next slides, I'll share you what are these tools that I was talking about. So what are the tools that you can use to basically create boundaries and create modules in your product? So these tools can help you to define these boundaries around the modules and to define also which components should be in a certain module. And I'm going to introduce you 4 tools. And in the next slides, first, I will just go through the theory with some practical examples. And later in the second part of this masterclass, I'll show you how I applied these tools and what were my learnings based on using these tools. And I hope that you can probably benefit from those learnings and you can learn something from those. Okay, so the first one is design structure matrix. Design structure matrix basically maps the interaction between all the components in your products. And based on those interactions, you can cluster modules in those products. Let me show you how it works. So the four kinds of interaction that I was talking about is spatial, energy, information, and material. Spatial interaction means that 2 components are physically located on each other. So either they are screwed or glued to each other, or somehow they are located on each other. Energy interaction means that, for example, you have a current flowing between 2 components. Information means that, for example, you have data transferred from one component to another. And material means that, for example, you have any kind of material flow. So, for example, water, gas, anything transferred between 2 components in your system. And the goal basically of using this tool is that you want to increase the complexity of the modules or the complexity of these flows inside the modules. And you want to decrease the complexity outside of the modules, because if you have decreased complexity outside of the modules, then it means that you can easily replace those modules in the product. And what you need to do, basically, here is an example of a design structure matrix. So you have to fill in the design structure matrix. First, you have to map all the components that you have in the system. It's mapped on this axis as well, and this axis. And you have to map the interaction between them. These are represented by these numbers. I'm going to explain you on the next slides what is the meaning of these numbers. And basically you start from here and you end up with this one. And there are certain algorithms that can do it for you. So basically first you fill in the matrix and you apply an algorithm and you end up with this matrix. And here these are the modules in the system. And you see that most of the complexities, so the interactions, are included in one module. And you see that outside of the modules, we are aiming that we have basically no numbers in the matrix. So it means that there are no connections, or that the connections are minimized between the modules. And there are certain trade-offs that the algorithm has to consider. One example for that, for example, you can make a preference over information. You can make a preference for information flow over material flow, because just an example that you can transfer information wirelessly, so that way you can simplify the interface between modules, but it is not possible to transfer materials wirelessly. So material flow is a little bit more complex, or can be a little bit more complex than information flow. So I'll take you an example how the mapping works exactly. Here I present you an automotive air conditioning system, in that you have an engine fan and the radiator. And there is a spatial connection between these two because the radiator is exactly mounted on the engine fan or the other way around, but they are connected to each other. And there is also material flow because the engine fan is blowing air to the radiator. And the meaning of these numbers are the following: if there is a 2 in the matrix, then it means that the flow is required. Otherwise, the system is not working. If you put a 1 in the matrix, then it means that the flow is desired. So it is beneficial to have that flow, but it is not necessary. If you have a 0 in the system, it means that it's not necessary at all. So for example, it is not necessary to have an energy flow between the engine fan and the radiator. So that's why we put a 0 here. And you put a -1 if it's undesired. So if it's not good for the system, then you put a -1 here. And you put a -2 if it's really influencing the system negatively. So then you put a -2 in the matrix. It is also important to tell you that you can also use these tools in a flexible manner. So for example, if you want to also include larger numbers or you want to include more numbers in the system, then you can also do that. At the second part of the masterclass, I'll show you that how we modified these tools based on our own needs when we applied on our own product.
Brief question, András.
Yeah.
On the symmetry of the matrix in the previous slide. Could you elaborate on it?
Yeah, it is always symmetrical because you map the interactions between two components. And of course, those interactions are symmetrical. So if one component has a connection with another one, it is always symmetrical. So that's why if you take this axis, then the whole matrix is symmetrical to that axis.
Or do you take the top side for the interaction from A to B and the bottom side for the interaction vice versa, or does it not matter?
It doesn't matter.
No,
it doesn't matter. If you fill in all the data, it's always going to be symmetrical.
So you basically can leave one part out.
Yeah,
okay.
Yeah, you can leave it out, but it just looks better like this.
Okay.
Okay, so after we have used this, this is not that we have actually applied, but I took it for you as an example. So first, this example, an interior air chunk is identified. We also have a refrigerant chunk, so all the components which can help the air conditioning system to circulate the refrigerant. We also have a front air chunk, and we also have a connection module. And the connection module is connected to all the other systems in the product. So basically, that also creates some kind of platform for this air conditioning system. So this is the design structure matrix, and the second tool is the so-called function heuristics. The function heuristics also maps the interaction between components, but it also creates layout of those interactions. So that's the biggest difference basically between these two. And if you want to use it, first I'll introduce you to a simple screwdriver and how it works for this one. So first you have to create a functional model. This is the functional model that you see here. So in the middle, you put the function that the screwdriver has, and you focus on three kind of flows: energy flow, material flow, and signal flow. And again, you can customize it for yourself. So if you want to add a different kind of flow to the system, you can do that. So in this case, you have to transfer electricity. You have to also hold the screwdriver in your hand. So that's human force. You also have to use counterclockwise rotation, so to hold the screwdriver in your hand. The screwdriver also has a weight. So these are the energy flows which are actually influencing the system. And you also have material flows. So material can be your hand, the bit, and the screw. And you also have signal flows. So for example, the direction in which the screwdriver has to work, you can switch on and off. And there is also manual use. So basically, the direction in which you are holding the screwdriver. Second step, after you are making the functional model, you have to make a sub-functional model. So you have to break down this function into smaller functions. This is what you do here. This is quite complex, especially for even more complex product than a screwdriver, but it really helps you to understand how your product works. And in the second step, it can help you to break down these functions and cluster the functions into modules. And I'll show you that there are certain rules that you have to apply on the sub-functional model. So what you do here is basically you are searching for certain patterns in the sub-functional model. And in the next slides, I'll show you what these patterns are and what we are searching for in this sub-functional model. So the first pattern is the dominant flow. So basically, you are searching for functions which are connected with a flow, and the flow should not have any breakage during its connecting certain functions. And the reason for that, if you have a breakage in the functional flow, then it includes certain complexity in your system, and you want to prevent that. The second one is the branching flow. It means that you have branches of flows, parallel branches. So here is one branch, here is another branch, here you have two sub-branches, and you are searching for this pattern in your functional model. The third one is flow conversion. So basically you are searching for flow conversions in your system. The reason for that, because flow conversions can be quite complex. So you want to include those flow conversions within your modules, basically. Just an example for a flow conversion, if you have, for example, a heat pump, the heat pump is circulating a refrigerant to heat exchanger, and the heat exchanger is warming up, for example, water. And you want to have the heat exchanger as a separate module because otherwise it creates extra complexity in your system. Could be that it is quite too abstract right now, but later on in this presentation, I'll show you how we have applied this. And I hope that that makes the whole application or the whole understanding of this tool a little bit more simple for you.
Would you say that the function heuristics is more of a qualitative interpretation of the design structure matrix? It's more of a richer interpretation rather than just the numbers.
Yeah, this is the functional heuristics is a little bit more technical than design structure matrix. And this is what we have also realized by using these tools, that actually the level of technical details can be different. The perspective can be different by using these tools. So I'll also share with you what we have realized by actually combining different kind of tools and what were the results by using different kind of tools, because it can be interesting for you. So the third tool is modular function deployment. The modular function deployment, this is, again, it's a little bit more business oriented compared to the previous ones, which were more technically oriented. The modular function deployment is basically including all the steps that you need to take for modularization. So what I mentioned at the beginning of the presentation, first you need to identify the customer needs, then you have to create functions and solutions, and then you have to cluster those functions, solutions, or components into modules. And then you have to design the interfaces, and at the end you have to define the variants. And the modular function deployment is including all these separate steps. And the modular function deployment is using a very powerful tool. This is the module identification matrix. And the module identification matrix is used to define the modules in your system. So in this masterclass, I will show you, and basically mostly focusing on how to use the module identification matrix. So this is the modular function deployment with all the steps. First, you have to identify the customer needs and then the solutions. And this is going to be our focus during this masterclass. So how to use the module identification matrix And in the next slides, I'll show you what are the elements of this module identification matrix. So as an input, you have module drivers and technical solutions. This is the module identification matrix. And as an output, you get modules. Some examples of these module drivers, what these can be. You can have module driver as a common unit. This is also used in the automotive industry. For example, different car types are using the same units or the same components. And this is a module driver for using common unit because basically you can save some cost, but it also influences how you cluster those modules in your product architecture. You can also have carryover module driver. This means that, for example, I take an example from the automotive industry again. The wind mirror can be a carryover unit. This means that you have the same component over different generations of cars, for example. So the mirror in the car can be the same for different car generations because it doesn't really matter to you to upgrade that. You can also have technical specifications. So you can create different kind of products with different technical specifications. So you can create, for example, one kind of product, one kind of car, for example, with different engine variants, which has different technical specifications. You can also have styling, so you can design a car with different kind of bumpers. That's a styling module driver. You can also have plan design changes. So again, if you take a car, you can, for example, design the navigation system with plan design changes. So during the life cycle of the product, so the car, you can change the navigation system because navigation systems and the car audio systems are developing quite fast. So you can have as a separate module, so you can upgrade it during the life cycle of the car. You can also have technology push. That's also similar to the navigation system. So if you see that one of the components is going to change faster than you have planned in your product lifecycle, then you can set it as a technology push component. So basically, you can change it during the lifecycle of the product. You can also have process organization. So, for example, for some reasons in your process, you can have separate modules because, for example, the manufacturing process is better to produce some components separately during the production process. You can also have strategic supplier availability. So if you have a good supplier, then based on that decision to have that supplier, you can create modules, or you can cluster the components into separate modules in your system. You can also have separate testability. So if you want to remove one component easily from your system to test it separately, then you can form it as a separate module. The same as for service and maintenance. So for example, if you are producing a product and you have to service that product at the customer side, then you can also decide, okay, this component is breaking down quite frequently, so I make it as a separate module. So if that component breaks down at the customer place, basically I can just replace it and bring it back to the company and repair that component at the company. So I don't have to spend extra time at the customer place or at the site to repair that component on the spot. I can just easily plug and play certain components for separate serviceability. The same for upgrading. So if you want to upgrade a certain component in your product, then you can decide to have that a separate module. And the same for recycling. So for example, if you have different kind of materials in your system, you can decide to cluster certain types of material in the system into one module. So it is easier to recycle them because then you can remove all the same type of materials at the same time from your product. But of course, for these to decide which modular driver is important for you, you have to think about what the customer needs are. So this is also showing you that this kind of tool is more business oriented rather than technically oriented. It can also be the case that this is not only an external customer need, so a need from the consumer, but it can also be the case that some module drivers are important for your company itself. So it can be an internal customer need. And it is also important to mention that these module drivers can influence each other. So you also have to consider trade-offs. So for example, as I mentioned, you can have carried over components in your product. So you can have the same components over generations in your product, but that's negatively influencing the technology push, because if you are using the same component over different generations, then you are not able to update the component from technology perspective. So these are the trade-offs that you have to consider before you decide on using a certain module driver. And I'll show you how this modular or module identification matrix works. So first you have to list the technical solutions that you have in your system or the components, and you have to map them for the module drivers that you have. Just take an example from this matrix. So for example, if you have adapter to cutting edge, it plays quite an important role in different specifications. So if, for example, your company decides that different specifications is important for us, then it's good to think about to cluster this technical solution to a separate module. So basically, the whole matrix can give you an overview on the whole system that you have and decide which components should be clustered into separate modules based on the module drivers. First one and the last tool that I would like to introduce to you is the design for variety. The goal for design for variety is reducing the design effort that you have to put into your product if you have to redesign your product from one generation to another one. And basically, the design for variety is using two metrics: the general variety index. This is basically the engineering effort that you have to put into your product if you want to redesign it. And the second one is the coupling index. This is basically the coupling between two components. And this is important to get to know, because if you have a strong coupling between two components, then if you have to redesign one component and it has a strong coupling to another one, then it's quite likely that you have to redesign the other component as well. So that's why it's important to get to know the couplings between the components that you have in the system. And there are certain calculations. I'll show you what these calculations are. And you can use these calculations to make these engineering decisions. So the first step is represented here. In the first step, you have to determine how long the product will last and what are the engineering metrics that your customer needs. So first, you have to fill in the customer requirements. In this case, for example, this can be fast cooldown time. And the engineering metric for that is cooldown time in minutes. So you have to figure out that, for example, in the current market, the cooldown time is 120 minutes. And in the future markets, you have to reduce that to 90 minutes. This is very important to know, because then that can already give you certain insights into what are the components that you have to redesign in your system. So as soon as you have that, you have to map those engineering metrics. Again, these are located here. You have to map those engineering metrics to the components in the system. So for example, again, an example of this one, if you want to reduce the cooldown time because your customer wants you to do that, then you have to redesign the fan in your system. You have to redesign the heatsink, and you have to redesign other components as well in your system. And then the meaning of these numbers is basically the design effort that you have to put into redesigning a certain component. So if you want to redesign the fan, then it's not that difficult. But if you want to redesign the heatsink, it's a little bit more difficult because it gets a 6. So these are the things that you have to consider. And this is, if you summarize all these numbers, then you get the variety index. This is what you see here on the bottom. And based on the variety index, you already know that, okay, for example, in this case, it is quite tricky to redesign the chassis because this got quite a high value. So then you can think about, okay, the chassis is quite costly to redesign. So what are the solutions that I can implement in the system? And I'll also show you some of these solutions that you can use to prevent or actually reuse this number. And the third step, as I mentioned, it is also important to get to know what is the coupling in the system, so coupling between components. And for that, you have to map the components, again, in the matrix. Here you have all the components, and here you have the components again. And yeah, if you want to improve the heatsink or modify the heatsink, then the heatsink is going to influence the pressure curve of the fan. And it's also going to influence the X and Z dimensions of the fan. So basically, this is how it's going to influence the fan if you want to change or redesign the heatsink in the system. And this way you can get to know what is the coupling between those components, because you can also see the strength of the coupling. You can also set it to 1 to 9. So you can see that you have to redesign certain parameters of the fan, but the redesign effort is actually not that big because it's only a 3 and not a 9. So in the next slide, I'll show you what to do with that data. So as soon as you have calculated the GVI value and the CI value, I'll quickly go back because I didn't tell you something. You have two CI values, the supplying, so the CIS, and you also have the CIR, that's the requiring information. And basically, in this case, the fan is supplying these informations to the heatsink. So that's how you make a difference between the CIS and the CIR, because in this case, the heatsink is requiring information from the fan, and the fan is supplying this information. So this is how you fill in this matrix. And you summarize all these values that you have calculated in the previous matrices, and you can map it on a certain kind of graph that you like. And in this case, you see that the chassis has quite a big CI, CR, and GVI value. So then the question is, okay, then what can we do to prevent this? Because as you can see, the chassis is linked to other components quite strongly, and it's also quite costly to redesign the chassis. So I'll give you a practical example of this one, an air conditioning system. So for example, if the chassis is linked to the fan, then you can standardize the interface between the fan and the chassis. And you can also design the fan with a certain overhead. In the first case, you can cut a bigger hole. If you see that, for example, for the first generation, you need a smaller vent, but for the second generation, you need a bigger vent. Then you can already cut a bigger hole in your system or in your chassis. But with an adapter, you can still put a smaller vent in it. So basically, this way you can decouple the ventilator and the chassis from each other. Or the second thing that you can do is if you realize that, okay, it is not that costly to already implement a bigger vent in the first generation, like here, then I can already put a bigger vent in the system, and then I don't have to care about how can I replace the vent in the second generation of the system. So then you can design the air conditioning system with a certain overhead if it's not that costly for you, because then on the other hand, you can save some cost on the engineering phase during the production or during the development process. And lastly, I would like to give you a summary of all these tools, because you have seen that these tools are quite different from each other. So it is also good to clarify what are the pros and cons and what are the cases in which it is beneficial to use these. So the design structure matrix, that was the first one. It gives you a good overview on the whole product architecture and the connections between the components in your product architecture. But as I mentioned, for this, because this is to calculate this is quite complex to do that on paper. So you have to use certain algorithms for that. it is quite difficult to validate the outcomes of the algorithm, because basically you just put in data, you apply an algorithm on it, and you get the results. But then how can you make sure that those results are really good or not? So that's a negative aspect of using this tool. The second one was function heuristics. It gives you a detailed insight into how your product works and what are the functions of your product. But the mapping can be quite difficult and messy. So if you want to map the whole product, then yeah, it can be a little bit too difficult in some cases. So that's again a con for using this tool. The third one was the modular function deployment. As I mentioned, the modular function deployment is including all the steps that you have to take if you want to modularize your product. So it is good for strategic step-by-step planning. And the module identification matrix that you see here, it's good because basically you align the customer needs, the internal and external customer needs, and also it helps you to clarify the business requirements that your company has. And you cluster the components into modules based on these. So it's good for strategic planning. And the last one was design for variety. For a lot of companies, it is quite a big struggle to release new products. So they have to focus a lot on redesigning the product. And this tool is basically aiming to reduce that. And that's quite important. But it is also quite difficult to get to know what are the customer needs for the future. So you can say that, for example, the customer currently needs this cooldown time in minutes, but it is difficult to say what the customer will want in 5 years or even worse in 10 years, because yeah, it is quite difficult to get to know that or get a proper value for that. So yeah, that's a con for using this tool. And I know that probably some of you have participated in one of our workshop or masterclass, or maybe you already have certain knowledge on these tools. So I'm curious, what is your previous knowledge or on these tools? So I start the poll again, and please select the tools which have been familiar for you already. I'm curious about that. It can also help me, because if I see that some of these tools are not familiar to you, then I can also talk about those more in the next phase in this masterclass. Okay, I see that design structure matrix and modular function deployment are can be known for you, but the function heuristics and design for variety are not that known. So then I'll try to talk a little bit more about those in the next slides. But first, before I go to that part, I would like to get to know if you have any questions.
So if anyone has any questions, please unmute your mic and just ask them.
Yes, I have a question about function heuristics, but he is going to explain more about it, I guess.
Yeah,
you can already tell me what is the question exactly, and then I can tell you if I'll provide you more information on that or not.
Yeah, more about the comparison between design structure matrices and function heuristics.
Yeah.
You say that the goal is the interaction between, for design structure matrices, you look at interactions, so spatial, energy, information, and material.
Yeah.
And this energy, information, and material, is that also the flow that you look at? So are those the same things that you look at in function heuristics?
Yeah, exactly. So basically the material flow is the same. So it's, for example, it can be water, gas, or any kind of flow. But again,
yeah, but also information flow from sensors or material flow from one place to another in air ducts or something.
Yeah, exactly. Or if you prefer, you can already, or you can add the forced flow as well. So you cannot do that actually, because that's a spatial. That's not a flow. That's kind of a connection. But if you have special flows in your system, and if those flows are not included in these three kind of flows, then of course you can add that.
Yeah. Okay.
So it's not a very strict. You can apply these tools in a flexible manner. You can customize it for your own needs.
If there's no urgent questions, and given the time, András, I understand that everyone's eager to learn more about these tools in practice. So maybe just a quick break, one or 2 minutes to get some water or coffee, and then we continue and dive into the tools in practice.
Yeah, in the next step, I'll show you how these tools are applied in practice. So before that, feel free to take a quick break, and we'll start in 2 minutes again.
Yeah, so it's 25 for me now. In 27, we'll continue.
Yeah.
All right. So it's 27 at my screen. Not everyone's back yet, but we'll just wait a little bit. I think everyone's eager to learn more. We have until 5 planned for. András and I have more time, so we think we can do the presentation till 5. Show the examples, show some practical examples, and then do the discussion afterwards. If you like, you can stay around for the discussion. If you need to go, you can leave. Try to get the most out of this. Yeah, shall we continue?
Yeah.
28.
Yeah. So, as I mentioned, I've applied these or some of these tools at a company called Factory Zero. And I was working for them basically for half a year, and did some experiments how these tools are working and how can we apply these tools on their product. And they were, of course, aiming to have a modular product architecture. First, I will introduce you the current state. So what was the issue at Factory Zero? They had a low product variety. These are the products that they have. Basically, these are called energy modules. and they have three different kinds of this energy module. So that's relatively a low product variety. But due to the rapidly changing markets, they had to release a new product quite frequently. And they also had to put quite a lot of effort into redesigning those products. So that was the reason why they have decided to use modular product architecture. So they wanted to prepare for these future changes that will occur in their product. And they also wanted to increase the variety of these products. So they wanted to have more than 3 variants, because they have seen that the customer actually needs more product variants. And they also wanted to improve the serviceability and repairability. So these were the main motivations for them to decide to go for the modular product design. And that's when they asked my help. And then I joined their design team. And basically together with them, we have identified some modules in the system. And this is what I wanted to show you, that how these modules are identified in the system, together with the use of these tools that I presented to you earlier. So again, a quick recap. These were the tools that we have discussed in the previous slides. And yeah, before we started to apply these tools, because we have now 4 tools, but the question is, which tool do we need? That's the first step that you have to, or the first decision that you have to make. If you take a quick view on these tools, it can be said that these tools have different approaches. Some of the tools are more business oriented, some others are more technically oriented. And if they are technically oriented, they analyze the product architecture on different technical levels. So even if they are technically oriented, it can be different on different technical levels. So the question is, which one should we use? We decided to use more than one tool. These are the 2 reasons that we made this decision. The validation of the product design would be difficult with just using only one tool. And this is also suggested by other studies, to use multiple tools and use them in an integrated manner. So that's why we have decided to use 3 tools. These are the 3 tools that we have decided to use. First one, design for variety, modular function deployment, and functional heuristics. Design for variety is because they had frequent product changes. And this was their biggest issue in the product development process. We decided to use the modular function deployment because it takes a business perspective, and they wanted to, of course, as every company, they wanted to meet the customer requirements, and they wanted to involve the business requirements in the product design. And the last one was the function heuristics, because their system was quite complex. They wanted to include that complexity in the tools that we have decided to use. And for that, function heuristics is quite a good tool because it maps all the different kind of flows that you have in the system. And they also had different kind of flows, different branches. So we were curious, how can we use this tool on the basic flow map of the product that they had. So I'll go through all these different tools. And the first one is design for variety. The main question before we started to use this tool, what is the likelihood of change of each component during the product lifecycle? Because the components were changing quite frequently, so they wanted to get to know what is the likelihood of these changes, because then if they know that, then they can prepare for that in advance. And as I mentioned, these tools can be fine-tuned, so we decided to implement 3 changes. The first one was that we left the customer requirements out, the exact requirements. What I mentioned to you that, for example, you have to get to know that in 5 years, your customer wants the cooldown time reduced to 90 minutes. We didn't have that data, and we didn't want to include any kind of data which is not reliable. So we have decided to just leave that out, and and just see how it will work out at the end. Because if it doesn't work out, then you can still decide to include that data or use the tool a little bit differently. So actually, when you are applying these tools, then you can also decide to modify them, and at the end you will see how it works out. So this was the first change that we have implemented. The second one is that we mapped the functions instead of components, because for the design variety you have to map the components in your product. But we decided not to do that, and the reason for that is basically if you have the function is a little bit more abstract, because components can change in your system, but the functions are quite likely that they remain the same. So for example, if you have a pumping water function in your system, then the pumping water can be replaced by different solutions, engineering solutions. And we didn't want to make that mistake that we map a certain component in the tool, and that component is going to change over time. So we wanted to make the tool basically future proof or a little bit more stable by mapping the functions instead of the components. And as I mentioned, it is also important to map the coupling between components in your system. We have modified it a little bit because we have mapped the coupling index is basically mapping the coupling between two components. And what we did is basically we mapped the coupling between one component and the entire system. And that basically made the application a little bit more simple, and that was the reason why we have did that. I would like to explain you the logic, so what we have applied. Basically, we took the GVI and the CI index. The GVI index is measuring the cost of the redesign that you have to pay if you want to redesign a certain component. And the CI is basically the impact of change to the whole system in our case. And basically what we wanted to know is the expected change in the system. And this is what we did. So for example, if a certain component has a high cost to redesign it, and it has a low impact to the system, then it's not that likely that that component is going to change. But if, for example, it's quite cheap to redesign it or replace it in the system, and it has a high impact on the system, then it's quite likely that that component is going to change in the system. So basically, that's the low-hanging fruit, as I would say. And these are the components which were in focus later on, and these were the components which were clustered into modules in the system. And this was the logic behind it. So on this slide, I'll just explain you the entire calculation that we did. So first, as I mentioned, we have mapped all the functions that we had in the system. These are the functions that we had in the system. And we mapped them to engineering metrics. And these were the engineering metrics that we had. So for example, product compactness, product cost, system performance, and so on. And we also included the different stakeholders that we had in the company. So we had engineering department, marketing department. Now the matrix is only filled in for the engineering department, but basically we made a priority for the engineering metrics that we mapped first. And that priority also had an influence on the results that you see here. So basically, we mapped all the functions that we had in the system for the engineering metrics. So for example, if I want to change one function in the system, like for example, take the last one, exchanging air, then how is it going to influence product compactness? How is it going to influence product cost? And the second one is the design cost. So what is the cost of the change in the system? And these are the design costs that we mapped. Normally, if you use this tool, then you only calculate the design effort, but we also decided to calculate some other elements as well. So for example, assembly process change, because if you redesign one component, it's quite likely that you want to, or you have to redesign your process as well, testing, and that's also important, or that was important for the company, because if they implement a new component, then they have to test it before they release it to the market. Supplier change was also important for them, because it's quite difficult, or it was quite difficult for them to change from one supplier to another. So these were the costs which occurs if you want to replace certain function in your system. And this is what we calculated here. So basically, we included some numbers, and these numbers are representing the cost that you have to spend on the redesign of a certain function. And we calculated the results here, and the results here showed us what are the functions that we have to cluster into separate modules. And these were the results. So you see the ones which are highlighted with green. Those got quite a big results or score, and that suggests to separate them into modules. So these are the 4 modules that we have identified. But there we also have some other functions which got low scores. Actually, if you are using this tool, then according to the tool, it is suggested that if you have low scores in the system, then it is recommended to cluster those components into a product platform. So to cluster all these components into one module. But actually, we had some doubts about that. So we still left it as an open question to ourselves, if we should cluster these components into a module, or should we leave them separate, or should we cluster them more than one module. So this is something that we realized later in the product design. But these were the four modules that this tool was basically recommended to us. So the second tool that we have decided to use, the modular function deployment, and in that the module identification matrix, as again, because we wanted to meet the customer requirements and we wanted to increase the customer satisfaction. And it was also a question if it's going to give us the same results as the previous tools, or maybe it's going to give us different results. Maybe we'll identify new modules or not. So that was a question for us, and we were curious how what kind of results we are going to get by using this tool. So in the next slide, I'll introduce you what we have done exactly. But first, again, what the module identification matrix does. So in the module identification matrix, you map the components to module drivers. And it is also important that and the module identification matrix is basically clustering the components into module drivers based on the scores that you give. And these were the module drivers that we were using. So for them, likelihood of change was important. They also wanted to include technology evolution, styling, different specifications, and so on. And we also made a priority of these module drivers. So for us, likelihood of change was the most important one. It got a 6. Service and maintenance was also quite important. This got a 5. So we also made some kind of ranking between the module drivers, because it can be the case that some module drivers are more important than the others. So this is how the calculation looks like. So again, first we mapped the module drivers that we had, and then we mapped the functions and components that we had in the systems, and we checked what is the relation between those two. So basically, we scored the module drivers to the functions and components, and we checked the final results. So which module driver is playing a significant role in a certain function or component. And actually, what was surprising after using this tool is that we got exactly the same modules that we have identified earlier by using the previous tool. And the results were actually, so the difference between these numbers, so the results got even bigger. So that was actually good that we managed to verify the results of the previous tool by using this tool, because the score differences got even bigger. but we got new modules identified by using this tool. So this was still a question: what should we do with these components which got a smaller score? And the third tool that we have used was function heuristics. Again, we had quite a complex systems. We had quite a complex system with different kind of flow types and flow branches. So we were curious how this tool can work on this. Yeah. Okay. No.
I think someone just left. Maybe wanted to say.
Okay. So we wanted to verify the previous modules that we have identified. And we also wanted to get to know if we can identify new modules in the system. And that was the reason, or that was another reason why we decided to use. Okay. Can you hear me? Okay.
Yeah, I can hear you.
Okay. So we also wanted to verify the previously identified modules. And we also wanted to get to know if we can identify new modules in the system. And again, a quick recap. These are the three basically patterns that we are searching in the functional map of the product. So first we mapped the flow map, or we mapped the different kind of flows that we had in the system, and we were searching for these three patterns. So if we have a dominant flow, when you have a flow without any breakages, or if we have a branching flow with flow branches which are parallel to each other, and we were also looking for flow conversions. So if one type of flow is converted to another one, these were the three patterns that we were searching for. And in the next slide, I'll show you the map that we have made. And I'm curious, based on these three flow types, if you can identify any modules yourself. So basically, I'm going to give you a quick quiz, and I'm curious what you think about the different flow types, or if you can identify certain flow types in the system. So this is the two options that you have. These are the modules which are identified in the system. I'm curious, which one do you think is a better layout for the product? But before I start the poll or the quiz, I'll just give you a quick explanation of the product. So this is a heat pump. This is a heat exchanger. This is the warm water line, and this is the cold water line system. We also have another heat exchanger, and we have a boiler, and we have some smaller components, some sensors, valve, a pump, and some other smaller components in the system. And I'm curious, which one do you think? Which one is a better distribution or modularization for the product? So please, I quickly launch the poll, and please select the one which you think is better. And if you have any questions about the system, please let me know.
No discussion, Frank-Jan.
Okay, so I see that option one is the one that you prefer, but I also see some votes for option two. So I'll actually option one was the winner. So well done. I'll explain to you why it's a better option. So here you have a flow conversion because you have a heat exchanger in this flow, or in this. Here you see a refrigerant line, and the refrigerant line is basically converted to a water line with a heat exchanger. So heat exchanger does a flow conversion. So according to the tool, it is recommended to put the heat exchanger into a separate module. And we also have two dominant flow lines, basically the cold water line and the hot water line. And these are creating two branches because these two are parallel to each other and also separate. So these are creating two branches. And we also have another flow conversion here with another heat exchanger. So that's also recommended to have as a separate module. And what you have seen here, you see that, for example, the heat exchanger is separated into two modules. And that could help you because it is just simply not possible, or it is just not recommended to cluster one component into two separate modules. That's why the first option is a better one. So what we realized by using the function heuristics, basically we managed to cluster the smaller components, what you see here in the system. So these were the smaller components that you have seen in the matrix. We managed to separate them to two separate branches, so two separate modules. And this was basically the result of using this tool. And these two basically were creating a platform for the whole product. So the company decided to create a so-called hydro system. And these two were forming the hydro system in the product. And these were also serving as a platform for the product as two separate modules. And as a summary, based on the usage of all these tools, we have realized that we needed quite a lot of data, for example, from the customer. We also needed quite a lot of data from the company's objectives, so what the company actually wants and what are the motivations for designing the product in a modular way. And we also needed quite a lot of system details. So what are the engineering details of the product, because we had to know them in order to use these tools. And we needed quite a lot of data. But this is actually good because it verifies that these tools are not giving you any results based on just general and not very detailed data, but you actually have to give detailed data to these tools. And that's the only way how you can get good results out of it. We also realized that it was quite easy and it was also beneficial to fine-tune these tools for our own needs. And you can also combine these tools or modify them as you want. And again, you will see how it works out. It can be the case that you modify them until a certain extent that they are not going to work anymore. But this is something that you will see after the application of, or during the application of the tool. And yeah, before we started to use these tools, we also had certain instincts on the modules that we had to create. And actually some of those instincts or initial ideas were matching with the results that the tools were giving to us. And actually that's just good for verification, because then we can really give a reasoning behind creating certain modules in the system, because we can say that, okay, we have done a calculation, and then based on the calculation, the results were that, okay, these components should form one module. This is what we were thinking of at the beginning, but this is how we verify our decision with using these tools. But we also managed to realize some new modules that we actually didn't think about. So these tools can also help you to think outside of the box and realize new modules that you were not thinking of. So thank you for listening. This is the end of the masterclass, and feel free to ask any questions if you have.
Maybe before we move into the questions, let me quickly share the evaluation in the chat. So if you want to leave a comment on what to improve, what you liked, just leave it in the evaluation and then join in on the Q&A. If there's any question, just please unmute your microphone and share it with us.
And will you share this presentation?
Yes, I'll share these presentations. You will get the slides. And I've also prepared a handbook for you. And in the handbook, there's a detailed description, a step-by-step description on how to use these tools. So later you can just check how these tools are working based on the handbook. I also include some practical examples in the handbook. So hopefully you will be able to also apply these tools on your own products.
Okay, thank you.
We recorded the webinar, so you can share it with colleagues or anyone interested. It will be shared to the partners via the newsletter, I think. The newsletter of October, it will be. Yeah.
Yeah. And of course, if you have any detailed questions or you want to have a discussion with me, here is my email address. Just feel free to reach out to me, and then we can have a call on the use of certain tools or how to apply them in practice.
Do you have an estimation about the amount of time putting in these three tools?
It depends on the data. So if you have the data which is required for these tools, for us it took like 5 months. I was working on the application of these tools part-time, so that also matters. And we also had to work on the input data. So we had to get to know the motivations of the company first, and that took quite a long time. But as soon as you have all the data which is necessary, you can even do it in 1 week.
Did you use software, András? Right, or only Excel?
Yes, we mainly use software. But for example, for the design structure matrix, as I mentioned, it is not it's not easy to do on paper or in Excel. So there are some software solutions which are available, and those are actually included in this handbook, which we'll send to you after the webinar.
The links to the software.
Yeah, the links. Yeah.
So not the software itself.
Not the software itself, but the links. So you can reach out to the software supplier, and then you can ask about the price, or you can check which software is the most suitable for you.
And another question, do the tools, do they help to develop modularization alternatives and to evaluate them?
Yeah, first you have to cluster the components into modules, and then the next step is to think about what kind of module alternatives do you want in your system. So these tools are not directly helping with that. That's actually the next step in the whole process.
And I can imagine that if you use multiple tools, that might be, in your case, they were pretty similar, right? So that was nice, but it can also be that they deviate a little.
Yeah.
And it might be an indication for alternatives.
Yeah, that can be an indication for alternatives, or just a general discussion. Why is there a deviation between those results?
Mm-hmm.
And maybe those deviations can highlight certain things, or you can realize certain things based on the deviations. For us, it was a good for verifying our decisions or verifying the previous results. But it can be the case that you have deviations or differences between the results that you get after using these tools.
Yeah, and also in the flows, for example, within the same tool, that if there's material flow or energy flow, that the recommendations might be not necessarily contradicting, but different. And then you have to decide which one of those to follow.
Yeah. Which one is more important for you, so you can create priorities in your system, and that's where it helps you to further break down your problem and think about modularization.
Mm-hmm.
Yeah, just a question. There is a modularization. There's always a trade-off, integral versus modular, or somewhere in between. Some functions modular, some functions more integral, and there's a kind of cost trade-off. And the cost involve logistics. Well, there are several elements of cost elements. Are these cost elements also dealt with in these methods?
Yeah, these cost elements are, for example, considered when you're using the module identification matrix with the module drivers, because you can relate those cost elements to the module drivers. Because if you are deciding to use or deciding to give priority to a certain module driver, then that can have certain pros and cons or trade-offs. This is what the tool can help you to think about.
Yeah, but that's not easy. Yeah? So the module driver is quite global, I think. So it's about having more variety. Is we give it a 5, and styling we give it a 1. But the 5 and the 1, do they represent savings or cost comparison, or that's not easy.
Yeah, of course you have to consider many more things before you make a priority of those module drivers. And you can also break down those module drivers, so you can also have sub module drivers. And it's just beneficial to include that in the calculation or in the matrix, because yeah, that can help you to have a better result, basically.
Okay.
Any other questions? I think in general, people can think about questions, but in general, a very comprehensive but also very elaborate overview of these tools. Interesting to learn more about them and to see different approaches on modularization and thinking about modules. By far not sufficient, I think, to really understand them and apply them tomorrow. So that will be a challenge, but it's a first step, and I think the handbook is nice. You can read about it afterwards, maybe share it or discuss it with colleagues to think about the best ways to continue. But overall, a very nice overview. Are there any final questions? Ideas, maybe how you maybe someone or a couple of people want to share how to continue? Too much to think about for now. Yeah. Okay, then I think it's 5 o'clock. We can leave it at that. Thank you, András, for the efforts you put into this.
Yeah, thank you for joining and for your attention. And I hope that you can take something for your modularization journey out of this masterclass.
I'm sure it's possible. If there's any questions about this topic, you can reach out to András by his email address or to me. There's several more of these kind of sessions on modularization, product architecture scheduled for the remainder of the year. So please have a look at the agenda at hand.nl/lean and join if there's anything interesting. The next ones will be live. So this one is a webinar, but most of them are in real life. So that's maybe more convenient even. And if there's nothing else, then thank you for your attention. Thank you, András, again.
Yeah, thank you.
Hope to see you soon.
Good. Thank you very much. Ciao.
Thank you.
Bye-bye.
Bye-bye.
Bye bye.